Haptic gloves offer the promise of immersive touch in virtual and augmented reality. Unfortunately, current systems are expensive and unwieldy, requiring tubes, tethers, external power, and backpack-sized infrastructure. We present a new haptic glove technology. Here, we remove the outer cloth layer to reveal the inner haptic components. The entire system can fit on the hand and wrist, including drive electronics, computation, wireless communication, and batteries. This glove includes high-resolution shape arrays for each fingertip. Uniquely, our haptic arrays are low profile and low cost, and yet highly expressive, both temporally and spatially. Each haptic pixel is fluidically driven by an ultra-small, embedded electroosmotic pump. The pumps are solid state with no valves, meaning the only thing moving is the touch surface itself. Our haptic arrays can enable a rich palette of effects. Starting most simple, users can feel contact pressure when touching a virtual object. Note that fine-grained contact impression is rendered appropriately. For example, the edges of this box. In this demo, a user can feel the individual violin strings to help correctly position their hands. Similarly, users can feel skin deformation when grasping or hitting virtual objects. We can also vary finger pressure over time to simulate, for example, the feeling of a buckling spring mechanical button, slider detents, and other user interface feedback. We also support static contact textures. For example, smooth, rough, ridged, and bumpy, providing a material dimension for virtual objects. Spatial textures are similarly possible. In this set, we have metal grate, wood grain, pimply skin, and corduroy. Humans' amazing ability to spatially integrate geometry makes these textures coherent and convincing. We also experimented with simulated object compliance. By varying the area of actuation radiating out from the point of contact, materials can be made to feel more rigid or more soft. Finally, we can play object-bound haptic animations on the fingertips, which we found particularly useful for creating environmental effects, such as wind, mechanical vibrations, water drops, and electrical sparks. Taken together, these expressive capabilities offer a significant palette of haptic effects for building immersive virtual experiences. Please see our academic paper or fluidreality.com for more details.